So, you just spent 45 minutes leveling your build plate and now your prints won't stick. What gives? Well, did you adjust your Z offset? Probably not. Not enough time is spent talking about this subject, but today we're going to give it its due, and here we go. Welcome back, everybody. I am Leo of Prince Leo 3D. Thank you all for tuning in. I apologize for the couple weeks where there was no video. I had a lot going on. I am now a new grandfather. Thank you very much. My granddaughter is home safe. My stepdaughter is home safe. My son-in-law, all home safe. So now we can get back to calibrating our Voxelab Aquila. So you'll notice I have two microphones going on. I hope it's not too confusing for you or too distracting. I'm trying to get the best audio quality for these videos, so I'm kind of experimenting with a few different takes. So today we're talking about bed leveling and adjusting our Z offset. Now, bed leveling is going to be a minor topic in the video, adjusting our Z offset a major topic. Even though it's not that big of a topic, we're going to try and concentrate on it. Now, bed leveling is basically the end-all, be-all of calibration. Whenever anyone asks, what's going on with my print? Why is my print not doing X or Y? The first question is always, well, did you level your bed? Sort of a joke at this point, but not really. Bed leveling is the cornerstone of every good print. If our bed is not properly level, then we're not going to get good prints. Simple as that. Now, I have to admit, when I first got into 3D printing, I heard things like adjusting your Z offset, baby stepping your Z. I thought those were things that people that were really into 3D printing did, and not everyone needed to do it. Well, I was significantly wrong. We're aiming to fix that today by learning how to properly adjust our Z offset. Just like leveling your bed, adjusting your Z offset is a necessary calibration. You certainly could get along for a while without doing it. You'll get lucky, but after a while, it'll catch up to you, you'll have bad adhesion, and you won't know why. So adjusting our Z offset is not really that complicated. The breadth of this video will be bed leveling, even though it's a minor detail, because Z offset adjustment is so simple. It's going to be the latter half of this video. It's going to be very quick, but it is very important. So before we get into the video, I just want to explain, I'm not a 3D printing expert. I'm not a scientist, an engineer of any sort. I'm just a guy that loves to 3D print. I've been doing it for a pretty good period of time, and I've had pretty good results. So I don't want people to think that I'm some sort of expert that's just expounding this knowledge because I know the minutia of every little nut and screw and turn bolt of this machine. That's not the case. I love 3D printing. I've been doing it. I get results based on what I'm showing you, and I hope this helps you. So bed leveling is a huge topic. Like I said, it is the foundation of every great print. There are literally thousands of hours of tape on the internet on how to properly level a bed. And you could watch any one of them. If it's a bed like ours with 4 adjustable knobs, anything they teach you in those videos would apply to our Voxelab Aquila. There's no way I could do a better job than all those professionals out there that are going into bed leveling. I'm not going to try. I'm going to go over things that I do that work for me and things that are specific to the Aquila. So remember the time I told you I was going to use 2 microphones? Well, I lied. I spent about 15 minutes recording and nothing was working on the other end, so we're back to this single mic. I hope the audio works because this is all we got, folks. Now, when we talk about adjusting our Z offset, we need to understand a little bit about leveling our bed. They go hand in hand, like I explained before, so we need to have a cursory knowledge of leveling the bed. So I will be going into that today. As far as what our Z offset is and what a Z offset adjustment is, I'm going to explain that later in the video because it'll be easier once we understand how the bed is leveled. So right away, the first topic of bed leveling we're going to talk about is the nomenclature, bed leveling. Really a bit of a misnomer, not really what it should be called. Now, when people hear the term bed leveling, they think they can go to a hardware store, buy a bubble level, put it on the build plate, adjust our 4 rotary knobs, and be done with it. That's not the case. That would be leveling it to gravity, and that's not what we're trying to do. What we want to do is make the bottom of our nozzle and the top of our build plate equal distance on as many points of this bed as we can. So imagine a plane that runs parallel to the bottom of the nozzle and a plane that runs parallel to this bed. We're trying to get those 2 planes to be parallel together. How do we do that? Well, we're going to use a gauge that goes between the 2. We can use a sheet of paper, we can use a post-it note, which is my preferred method, or we can use a feeler gauge. This one is 0.2 thickness. They come in different thicknesses. You'll use whatever you feel comfortable with. So what we do with these gauges is we put it between the nozzle and the bed until we get resistance, and that's how we judge the distance. Now, this process more accurately referred to as tramming our bed. So when we say bed leveling, we really mean bed tramming. Does it really matter? No, not really. All we're trying to do is get good prints. However, you might hear this term, tramming your bed. It's good to know that people are referring to bed leveling. It's very similar to the word tea. Here in America, at least, when we say tea, we refer to anything we've put in, steeped in hot water. Chamomile, mint, it's all tea. That's really not the case. Tea is a specific plant, Camellia sinensis, and if that tea leaf or that tea plant is not steeping in that water with you, it ain't tea. It would be more called an herbal infusion. However, like I said, it's ubiquitous. If we're steeping anything in hot water, it's tea, and when we're adjusting these rotary knobs, it's bed leveling. So now we know a little bit about the terminology. Let's look at the parts of the bed. So I've taken the clips off to make this easier for myself. I'm going to remove the glass build plate, and underneath here we have our heated bed. So the heated bed is a soft metal. It's very likely it's warped, makes bed leveling a little tough. That's why it is so crucial that Voxelab has provided us with a glass build surface. So glass is more likely to be flat, so when we place this glass build surface on our heated bed, it should alleviate some of that warpage and make it easier for us to level the bed. Now, a few issues I ran into when I put the glass build surface on top of the heated bed, the two clips that Voxelab sent with the Aquila, one on the front, one in the back, was not enough to properly secure my glass build surface onto my heated bed. This edge right here in particular was actually lifted up about maybe a millimeter. After leveling for about 15 minutes, I couldn't get a level bed. I looked a little further. I realized this wasn't properly affixed to that heated bed. So what did I do? I had to go and get a few more binder clips. I put one in each corner, and then the glass build surface properly adhered to the heated bed, and I was able to accurately level my bed. So that's just one of those things where you might not see it at first. There's so much going on, so many different aspects of calibration that you could overlook something very simple like that, like I did. So definitely something to look out for while you're leveling your build plate. All right, well, the next tip before we begin bed leveling is we want to get this nozzle as close to our glass build plate as we can before we start leveling. How do we do that? Well, we need to look at this Z end stop. This Z-axis end stop is what bottoms our printer at. When the X-axis gantry lowers, it clicks that end stop and it stops moving downward. That would be the bottom of our Z-axis. So we want the bottom to be as close to this glass build plate as possible. How do we do that? Well, we're going to adjust this Z end stop. So the best way I found out to do it is to first power down your printer. We are now properly powered down. And then we're going to go behind the Z-axis on the coupler, and I'm going to twist it so that it slowly comes down. Next thing I'm going to do is move the bed to the center, or move the nozzle to the center of the bed. I move the X-axis to about the center. The Y-axis, which is our bed, forward to back movement, I move that back so I'm right in the middle of my build plate, and I continue to lower it. Now what I'm looking to do is hear this end stop click. I want to see how far away from the bed our nozzle is when our end stop activates. So my end stop is actually perfect. I am just above that glass build plate. What happens though if your nozzle is way above that glass build plate? Well, you're going to have to start adjusting these rotary knobs a ton in order to make up for that gap. So what we're going to do is adjust our end stop so that gap is significantly lower and it's easier to begin leveling our bed. Another great point to mention with our very soft metal bed, whenever we want to loosen these knobs, we don't want to do a significant loosen on one particular knob. It can make this bed even more warped. So if we're going to replace our springs, for example, or decompress one side a ton, we want to make sure we do it a little at a time. So I would turn this knob a little, then I would go here, then I would go to the back, and so on and so forth. We don't want to completely decompress one knob because it can make that very soft aluminum build plate start bending up, and that would be harder and harder to level this bed. What we'll first do is raise our X-axis gantry by using the coupler in the back. If we're looking down on the coupler, if we're spinning it clockwise, it will raise our axes. After that, we take our Allen key We loosen our Z end stop right here. It'll completely loosen. Now when we loosen this, we don't want to loosen it fully. A few turns just so that our Z end stop will move. That's perfect. Remember, these are T-nuts in here. If we loosen it so much, the T-nuts will come off. I have to put them all back together. It's a little bit of a hassle. So just loosen it enough that I can now lift up my Z end stop. So our Z end stop's loosened. We bottomed it out. We make sure it's all the way to the bottom. It can't go any further. We're going to lower our X-axis so that the nozzle is just above the glass bed. If you want to put something between the nozzle and the glass bed, probably a good idea so you don't scratch it. Put this piece of paper for now. And I'm going to lower my X-axis gantry. So I am just above it. I can still move this paper pretty well. As a matter of fact, I'm going to go a little lower. Okay, I'm just above it. I'm not feeling any friction, which is fine. If you want to go low enough where you feel a little resistance, you can. I don't recommend it. I'd like to be just a little higher so that when I start adjusting these knobs, I have some wiggle room. What I do now is I take my loosened end stop and I'm going to raise it until I hear it activate or click on this X-axis gantry, which is right here. For me, it's right here. It's hard to hear, but if you're listening, you can hear it. I'll hold my finger on it. And I will tighten up the Z end stop switch. Now I want to make it tight. I don't want to just loosen it, come back and retighten it, because what we're going to do is bring the X-axis up, drop it down again, see if it activates properly. And if it's not fully tightened, the Z end stop that is, it can fall down. And then when we finally do an AutoHome, it'll activate this switch, but the switch will have dropped and be lower, and we could crash into that bed. So make sure it's nice and tight. Now we're going to bring up our X-axis gantry. And we're going to slowly lower it down, listening for the activation of our end stop, and then seeing how far our nozzle is above our bed. So I'm activated right here. I have the paper underneath, and I can still move it. That's a good thing. That means I'm not crashing into my bed, but I'm pretty close. We're a few turns of these knobs, and I should be bed leveling very appropriately. Little add-on tip here, I always want to keep mentioning it. If your machine is off and you start moving some of these axes back and forth and you see the computer light up, that is a bad thing. You are generating current with the stepper motors because you're moving one of these too quickly. You can send current to your main board and fry it. So always be careful when the printer is powered down and you're moving axes, do it very slowly. You do it too quickly, you send current to the main board and you fry your machine. So we adjusted our Z end stop so that we have an easier time bed leveling. Now we can turn the printer back on and we can AutoHome our machine because that's where we're going to begin leveling the bed. So when we AutoHome the machine, what does that mean? Well, every time we turn the printer on, it doesn't remember where it was. It doesn't remember where the nozzle was on the X-axis, where the bed on the Y-axis was, or where it is on the Z-axis or the vertical axis. So when we AutoHome, what it does is each individual axis will find its end stop. The X-axis one is here, the Y-axis or the bed one is in the back, and the Z-axis, the vertical one, is right here that we just adjusted. Once it finds all those, it knows where it's at. It's zeroed out on each axis, and it can then perform printer operations. So when we AutoHome, it's basically bringing every axis to 0. That's the origin point, and that's where we'll begin bed leveling. So now we're at AutoHome. We adjusted our Z end stop perfectly so that we're not going to have too many major movements on our rotary knobs and decompress or compress these springs all that much. Now the way I like to level the bed is by checking 4 corners of the bed. Now if I wanted to try and move the nozzle or the X-axis right now, I couldn't. That's because the stepper motors have locked up. What are stepper motors? Those are the motors that move every one of our axes. Our X-axis stepper motor is right here, the Y is back here, and the Z is right down here. After we perform any movements like an AutoHome, or if we wanted to raise the bed, after we perform those movements, the stepper motors lock up. So we can't move them manually. What we need to do is go into the menu, go to prepare, and then go down to disable stepper motors, and we'll be able to move these motors around, in particular the nozzle. We AutoHomed, we disabled the steppers, we can move the axes. Now the next thing we need to do is get our feeler gauge of choice. Doesn't really matter which you use. The thickness is obviously going to differ on all these, but guess what? That's where adjusting our Z offset comes in. Even if I use a 0.2 gauge feeler or a 0.1 roundabouts, I guess, for this paper, it's not going to matter. We're going to correct all these deviations with our Z offset. So I prefer the post-it note. I've always done it with that. I'll stick with it now. What we want to do is go into this front right corner. I'll call this 1, then I'll go to 2, 3, and 4. I'll go to number 1, front right corner, and I'll put my post-it note under it. And I got to be honest, I'm feeling a decent amount of resistance right now. I think we are dead on with our end stop adjustment. So I put it under the nozzle and the build plate. If I feel no resistance, that means there's too big of a gap. I put it under there and I start turning my knob. If the adjustment knob is going clockwise, it's loosening the spring, meaning it's bringing the bed closer to the nozzle. If it's going counterclockwise, it's tightening the spring and it's going to pull the bed away from the nozzle. Now Voxelab has provided us with the writing on the knob so you can know, and an arrow so you know which is up, which is down. Kind of hard to see though, but that's a good way to remember it. If you're going counterclockwise, you're pulling the bed away, you're giving yourself more of a gap. And if you're going clockwise, you're bringing the bed closer to the nozzle and you're closing that gap. So I put it under. I feel pretty good right now. I feel a little bit of resistance. How much resistance should you feel? Well, that's up to you. It's based on how you can determine the resistance on all our points. If it's going so much that you can't pull the paper out, well, that's probably too much. When we go to first try and print, your nozzle will be so close to bed, it might clog because there's no filament coming out. You want a little bit of resistance. This way you can accurately judge how far it is. So I feel a little bit. I like where it's at. I'm going to move to the next point. I go directly across, and now I do the same thing here. I go right under. Now in this point, I feel no resistance at all. So what am I going to do? Well, it means that the gap is too large between my bed and my nozzle. So I go, and I'm going to bring the bed closer to the nozzle by going clockwise. And the whole time, I'm pushing the post-it note in and out. I'm starting to feel it, and now I feel resistance. Now, what am I looking for? I'm looking for about the same resistance I felt in our first point. And I about feel it. So after I do that, I'm going to move the bed forward, and I'm going to go to this back point. Another thing to consider is, as I'm making the adjustments, I let go of the knob, and then I feel. Because as you're adjusting it, it's possible you're pulling that bed down. You want to let go of the bed, and then feel. So right now I'm in the back right corner, I suppose it is, and I feel a good amount of resistance. It's about what I felt in these front two. Very good. I'm going to keep moving on. I move it over to right about here, and I do the same thing. And the resistance is about even. This usually doesn't happen. Generally, you're making a lot of adjustments. I didn't have to for whatever reason. So here we go. Now, I went around once. Am I done? Absolutely, I'm not done. You have to go around at least twice. Why is that? Because the opposite corners affect each other. So remember how we went around the bed? 1, 2, 3, 4. Well, 1 and 3, opposite corners, they affect each other. 2, 4, opposite corners, they affect each other. If I made an adjustment in the back corner, it affected this front corner, and vice versa. So what I want to do is go around again and make sure that those back adjustments didn't affect the front, and vice versa. So now I'm up in the front, and I got to say the resistance is a little too much. So I'm going to back this off by going counterclockwise. I'm getting the resistance I want. Matter of fact, I want a little more. Clockwise. I'm good. Keep moving on. Okay, I don't have the resistance I want here. I lost it. I'm going to go back. I'm going to make it go clockwise. I'm going to get myself closer to that nozzle. This is good. This is good. Am I finished? Nope. Do it again. You really can't bed level enough. And again, I only did the fronts, so if I check the backs and they're good, we should be done, right? Well, I like to be extra certain. This is the foundation of our prints. We want to get this right. I'm good. All my four corners are perfect. They're all the same. What are they perfect to? To me, a little bit art, a little bit science. I'm going underneath and I'm feeling a certain amount of resistance that I can tell is the same on all four corners. I don't like it to be too much. I like to be able to feel some though, and it's accurate. So now am I going to do the final point in the center? I don't personally do it. I know a lot of people do. I feel that you can't properly adjust the center by using these 4 outer knobs. I have to just hope that my bed is flat enough, this glass build plate specifically, is flat enough that if I get these corners proper and the bed is small enough, that it should be fine. I do always check just to make sure, and I have good resistance under there. But again, I personally don't feel that I can adjust that center by adjusting the corners any differently than how I did it by just doing those 4 corners. So I started at the first point. It was here. Dead on. We went to the second point. We were there. We were dead on. We went to the third point. And then the fourth point. So I'm satisfied that my bed is level. I can start printing, right? Well, I could, but that's not why we're here. We want to adjust the Z offset because right now we started this at AutoHome. Remember, we made sure all our stepper motors were zeroed out. That's what AutoHome is. Now here's a critical thing to understand. AutoHome is not where our prints start. Everyone thinks it is. AutoHome is where our printer applies the initial layer height. I'll say that again. AutoHome is not where your prints start. AutoHome, where everything begins, is where this printer is going to apply our initial layer height. So what does that mean? Well, when we leveled this bed, we created a gap. That's how we felt the level. In my case, I used a post-it note. At AutoHome, which is where it's zeroed out, I created a gap the size of a post-it note. That's what I did to feel the resistance. So now, at AutoHome, there is a margin between our nozzle and our build plate. So I have a 0.4 millimeter nozzle. I use a 0.2 millimeter layer height, and I use that as my initial layer height. So that means when a print starts, it goes to AutoHome. There is a margin in between here, the size of a post-it note, and then, before it pushes out any filament, it applies the initial layer height, which is 0.2 in my case. So that means my printer is printing at higher than 0.2 because I have a gap of this post-it note between the bed and the nozzle at AutoHome. So how big is this post-it note? Let's just say it's 0.1 for argument's sake. So now when my printer starts the first layer, it's printing at 0.3 millimeters away from the bed when I only think it should be printing at 0.2. That's a significant deviation. I'm not going to get good adhesion, and it's possible my prints won't stick at all. Now imagine if I used a 0.2 feeler gauge. If I had a gap of 0.2 at AutoHome between my nozzle and my bed, then when my printer starts with applying the initial layer height of 0.2, I would have applied this gap, this deviation, and then my initial layer height. So I would be 0.4 millimeters away from my bed. That is a significant margin of error. I think I'm only 0.2. That's what my initial layer height is. But I've added this gap between my bed and my nozzle because that's how I leveled. So I've basically doubled that. So my prints aren't going to stick whatsoever. How do we fix that? Well, I'm sure you've guessed. Z offset adjustment, and specifically a live Z adjustment. What's a live Z adjustment? Well, while this printer is printing, we're going to give it a calibration print. We're going to go into the menus of the Aquila, and we're going to lower our Z offset and bring this nozzle closer to the bed to make up for the gap that we created while we bed leveled. So this is a pretty big concept to understand, but it's very simple. Our prints don't start at AutoHome. AutoHome is where the initial layer is applied. So you have your initial layer, and then you have your gap of whatever feeler gauge you used. And adjusting our Z offset, that is what takes away this gap and applies only that initial layer. We're going to get adhesion, we're going to get prints that stick, and hopefully we'll get that perfect first layer. So we leveled our bed, and now we're ready to go into our slicing software, create a trial print, and then use that to adjust our Z offset live. This is my slicer of choice. I use Cura right here. This is my Aquila profile. It shows that I'm using a 0.4 millimeter nozzle and that my layer height is 0.2. Something else to note, initial layer height, I have it as 0.2. Now I've always done my initial layer height the same as my layer height. I know, however, the common rule of thumb is to usually go a little bit bigger, maybe 0.3 or even 0.24, 0.28. The idea behind that is you're going to push out more plastic and you're going to give yourself a better chance at adhesion. I can't say it works or not because, like I said, I don't use it. I make my initial layer height the same as my regular layer height. So the trial print I usually run is 5 cubes. They are 20 by 20, show you. So they are 20 millimeters by 20 millimeters by 1 millimeter high. Now, that's just the generic size I make them. I'm going to make it a single layer high. So if we're doing 0.2 layer height, I'm going to make the Z, which is the height of it, 0.2 as well. So it's only going to print a single layer. After that, I'm going to multiply it by 4, and I'm going to put them in the 4 corners, and I'm going to keep this one right in the middle of the bed. So with our size bed, I like to make it 70 on the X and 70 on the Y, and I'll put them uniformed around the bed like that the whole way around. So this is how I like to set it up. This will show me how I'm printing in the 4 corners, and it'll show me how well that center of my bed is going to print. And now the most important part to this is I'm going to add a skirt around this, and that is under build plate adhesion. So I'll click build plate adhesion. So here it is. Skirt's already selected. Drop down, I'll show you a few more options. Brim and raft, those help with adhesion. The skirt does not. The only thing a skirt does, it's going to print a small layer around the outside of our print. And what we're going to do, we're going to use that to check adhesion. It itself, though, provides no adhesion. So this is some of the skirt options. Line count, I keep it to 3. It's going to go around 3 times. And the distance is 10 millimeters away. That's how far away the skirt's going to print. You can decrease that number, and it gives you actually more space in your build plate if you're ever trying to fit something onto your build plate. And then under here, you're going to see I already have this. This is an extension, Z offset. This is eventually where we're going to add the number we get from our live Z adjustment. This can't be found in the base Cura. You have to go up to the marketplace and download it. We'll go through that, though, in the next step. So I have my skirt selected as build plate adhesion. I know my material. Under here, I have my proper temperature. I have all my other printing parameters ready to go. So I'm ready to slice this, create a G-code out of it, and then send it to my printer. After we get the G-code, we're going to save it onto our SD card. We're going to bring it to our printer, and we're going to let it print. Here's a quick preview of what it's going to look like. This right here, this line I'm pointing to, that's the skirt. This is what we're going to use to help adjust our Z offset. We're going to baby step it, which is another term for it, as this line prints. So we can go down to the bottom. You're going to see me do this live on camera, but it's pretty good to show. So this is how the skirt's going to print, just like this around the outside of my build plate. What I'm going to do while this is printing, I'm going to be rolling my finger over all these lines, or this line of filament as it comes out, and I'm going to test how much it's adhering. So if I roll my finger over it and it comes right off, it's not sticking that well. I can also roll over it and it's sticking well. I can feel kind of how high it is. Maybe I need to smush a little more. This is PLA. It wants to be nice and smushed, meaning it wants to be pressed against the build plate pretty good. So that's what the skirt's going to look like. We're going to save this to our SD card, and we're going to try getting a print out of it. Now, the first thing we're going to do, of course, before we even start our print is clean our build plate. Especially after leveling, we have so many oils from our hands that have been transferred to the top of that build plate. It's going to make adhesion very poor. Okay, so our trial print is starting. That's the beginning of our skirt. We're not going to mess around too much with that because right at the beginning, it has bad adhesion, so we don't want to roll a finger over it. We start right about the middle there of the build plate, and we're going to start rolling our finger over the filament. And already you'll see it's starting to come up a little bit in places. I am getting decent adhesion, but I can feel the roll of filament, the bead of filament that is, and it's a little higher than I'd like. It's not as smushed. So I'm continuing to roll my finger over it, and I can feel it. It's adhering pretty well, but not as well as I want. So this is the time where I'm going to go into the menu, and I'm going to adjust our Z offset. So right at the bottom there, this little marker says Z. It tells you what the offset is currently. It was at 0. I go to the tune menu, and I go all the way down to the Z offset setting. I'm going to decrease this in small increments. Decrease brings it closer to the bed. Increase farther away. I decreased it by 0.02 millimeters. It's a very small margin, but that's really all we're working with. I go back to the print, I keep rolling my finger over, and I already feel that bead of filament is much, much better. My adhesion is nearly perfect. That's really all it's going to take. Any further, I could push too much filament into the bed, and farther away, I wasn't adhering as well. It almost feels like we got it dead on first try. We'll let this go around for the other two skirts. We'll keep rolling our finger over it a few times. Of course, watch out. This is a hot bed. Mine is heated up to 60 degrees Celsius right now. You don't want to burn your finger. And then after this skirt is done printing, we're going to print the 5 squares. Now, we're really adjusting our Z offset based on this skirt. We've just done that. We don't really need to do it while these 5 squares are about to print. What we can do during those squares is we can do a live bed level. So if we see one of these squares is a little smushed in or one's further away, we can turn our rotary knobs slightly to adjust for that. Do I recommend doing that all the time? Not really. We don't want to make gross adjustments. We've already leveled our bed. Now all we're doing is making sure during the printing operation it remains level. So while this prints, I watch it. I get eye level down to the build plate. I like to see how well my filament is getting placed onto that build plate. We adjusted the Z offset previously. I like how it feels, and it looks really good printing out. So we'll step back, we'll watch this print the rest of our squares, and we'll see how they look when it's all finished. So we did our test print. We adjusted the Z offset live, and the number we came up with is negative 0.02. Not a large adjustment at all, but it's a very, very important one because that means it's going to smush our PLA closer to that bed. So what we need to do with that number is input it here into our slicer so that each print we slice has that saved into it, and we do not need to adjust it through the LCD panel. Now to do that, we go up here to Marketplace, open it up. Okay, the Marketplace opens up, and what we're looking for is Z offset. Go down here, scroll down under Plugins. So Plugins right here. I'm going to scroll all the way down. Now, I've already downloaded it. Right here, Z offset setting. Now this adds a Z offset setting to change the distance between the nozzle and the build surface, or the build plate. So I already have it installed. If you don't, you're going to have a little button here that says download. You will download it. It will take a little bit. You'll then have to restart Cura. And when you do, you go to this print settings menu over here, and it'll be under build plate adhesion. Click that, and we saw it before. It's right here. It adds these two things, Z offset and extensive Z offset processing. What we're interested in is this Z offset. We got the number from our last print. We got negative 0.02. We insert it there, and guess what? We're done. That's it. So now each time we slice a different model, this plugin will adjust the Z offset for us, negative 0.02 amount, so that we get that proper squish and that proper first layer for all of our subsequent prints. So that's it. There's really not that much to Z offset. It's not scary, it's not confusing, but it's important. We made sure our bed was level, but now we have to make sure that we have our nozzle the proper distance away, and that's what this Z offset has done. Folks, that is it. We leveled our bed, and then we adjusted the Z offset live. If you blinked, you probably missed that part. It was so quick, but that doesn't make it any less important. So now I used a Post-it note to level my bed. I believe a Post-it note has a thickness somewhere below 1 millimeter, something like 0.07 millimeters thick. So my live Z adjustment was not that much. I only had to go minus 0.02 to get the proper smush that I wanted. Now if you use something like a 0.2 millimeter feeler gauge, you're going to obviously have to adjust that Z offset by a lot more. But that's something you'll do during that live Z adjustment. As that skirt goes around, you'll continue to decrease or make the number negative in the Z offset, and that will bring the nozzle closer to the bed. It was a big concept to understand, but very quick to watch. We leveled the bed, we made sure the nozzle was an appropriate distance. We're using PLA, we want a good amount of smush. So we want that nozzle to be a little closer to the bed than normal. Other materials, less squish. PETG or PETG or even TPU require less squish. So when you do print with those materials, your Z offset will most likely be different. So for example, when we finished our video, I input 0.02 Z offset into Cura. If I'm using PETG or if I'm using TPU, I'll probably make that Z offset 0. I'll want it exactly where it was because it doesn't need to be pressed into the bed as much. So what did we cover in the video? We talked a little bit about the possible warpage of our heated bed. We talked about how the fact that glass is most likely flat and a more flat plane, and it will help us level our bed. I told you how I was having trouble with just these two clips, so I had to add a few more binder clips around my bed to properly adhere that glass bed to the heated build plate. Then we went around and we leveled 4 corners of the bed. How do we do that? We used a feeler gauge to go between the bed and the nozzle and to measure its resistance. We matched the resistance of every corner to each other corner. This felt like this, felt like that, felt like that. That's how we made sure the plane of our bed and the plane of our nozzle were parallel or equidistant. After we knew our bed was level, we started the print. We went into the menu, into the tune section, and we found the Z offset adjustment. As that skirt printed, we rolled our finger over the PLA, over the filament as it was getting deposited onto the build plate. If it came up too easy, that means we're too far away from the bed and we needed to decrease the Z offset, making it a negative number. That's what we did. Ours started out pretty decent. We decreased it a little bit, we got a little bit more smush, and it was perfectly where we wanted it. We knew our bed was level when we started that print. We had done that beforehand. We just needed to make sure the distance between the nozzle and the bed was appropriate. After we did that, we went back into our slicing software. We inputted the data we got from our tune screen. For me, it was negative 0.02, and we left it in our slicer. That way, every time we make a new print, it'll already have that Z offset in the G code, and we don't need to go into the menu and adjust it any further. Now, of course, if we do anything to the bed, if we change the nozzle, anytime we're going to re-level this bed, we're most likely going to have to do a trial print again and readjust that Z offset. Now, if for some reason you were pushing too much filament into that bed, you'd have to make the Z offset a positive number, and you're going to want to raise that nozzle away from the bed. That wasn't the case for us, however. So if you have any questions, any comments, please leave them below. I know I've made some mistakes in the past. It's a one-man show here. I do my best to get the most accurate information, but I'm not always right. I'm very fallible, and I appreciate all the comments that call me out because it makes me a better person, makes this channel better. So if you're watching the video, read the description below. There's always more information there. And then go even further, read some of the comments. So much good information and so many good conversations are started in those comments. I appreciate everyone for asking questions, pointing things out, because that makes us all better. I want to thank you for staying this long. If you liked the video, hit like. If you want to watch more of these videos, I have more on the Voxelab Aquila coming out. Hit subscribe. Every time a new video comes out, you'll get notified. I believe we're going to put a BL touch on this thing next. To be honest, doesn't really need it, but I know some people are interested in that, so I want to do that. I'm also going to roll that video into the firmware update video. Thanks again for sticking around. Like, subscribe, all those things, and until next time, keep on printing.